So it looks like we're going to have a part 3. The video cut out one last time. Alright, so let's get back into this problem. We're doing side-side angle, and we're looking at when do we have only 2 triangles. So if I have my triangle A, triangle B, triangle C, I have an angle. The side opposite is 12, and another side opposite angle B is 15. So we have to see, first of all, we have side, side, side. So then once we know we have side, 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 we look at the side opposite the given angle, and that is smaller than the other side given. So A is less than B. That means I have 0 or 2 solutions. So then what I need to figure out is if I have 0 or 2 solutions, what is the height? Because the height's going to tell me whether I have 2 triangles or 0 triangles. So I take the sine of 50 over, or sine of 50 is opposite over hypotenuse, so h over 15. So sine of 50 is opposite over hypotenuse, so the height is going to be, if I calculate, 15 times sine of 50 gives me 11.5. And that says that then that the A is actually greater than the height. The side opposite the given angle is greater than the height that I solved for. So that means I have 2 triangles. So that means I can start to solve for the 2 triangles. So here I have sine of 50 over 12 equals sine of B over 15. Calculate, pause the video. I'm just going to go ahead. Angle B will give me 73.2 degrees. And therefore angle C would be, if I do 180, subtract 50, subtract 73.2, that will give me C of 56.8. Go ahead and calculate that. And then I just need to find the third side, which would be sine of, I need to find little c, so the sine of 56.8 over C equals the sine, we're running out of room, the sine of 50 over 12. Again, I calculate that. 12 times sine of 56.8 divided by sine of 50, and C equals approximately 13.1. So that's the first triangle, and this is the large triangle. Okay, so I also need to find the small triangle now. So we are running out of room, but before we switch sides, I want to look at where would the small triangle be. The side that swings, so this side right here is 12. Now, since it was larger than the height, it could either come out here or it could swing in. And if it swings in, then I could have, this could be the height of 12. So I have this small triangle, and then I have the big one that you see. So I have the small green triangle, and I also have the big one that you see. So now we need to find the dimension, or all the sides and angles of the small triangle. Now remember that the side angle A was 50 degrees. We're going to take this out and actually look at this a little bit bigger. So let me redraw this. A, B, C. So I had 50 degrees and a side of 12. So what I did is 12, remember 12 is the side across from the angle, if you have 2 triangles, is a side that swings back and forth. So it could be 12 as a big triangle or 12 as a small triangle. So here, if it swings in, given that this would be my height of 11.5, so I'm talking about this green triangle right there. Okay? So again, I wrote 50 way too big. I should have wrote a really small 50. Let's do that. A really small 50. That little a is 50 degrees. I already know that. The first thing we're going to solve, well, I need to put what side this is. We're going to, the big triangle is B, we're going to call this B prime. So I'm solving for triangle A, B prime, C is what I'm solving for. So if I do that, I'm first going to find angle B prime. And the way I'm going to do that is, if I know this side right here is 12 and I just swing it in, I have this side would be 12 then. And therefore I have an isosceles triangle. And we know in an isosceles triangle that the base angles are going to be congruent. So in angle B, we found that angle B over here was 73.2. That means this has to be 73.2. And therefore B prime right here, A, B prime, C, this angle right here, these will be linear pairs. So I take 180 and I subtract 73.2 and I get B prime, angle B prime, to be 106.8. And then I can find angle C, because if this is 106.8, this is 50, angle C right here, this little angle, we'll take those from 180, 106.8, and we get 23.2 degrees for both of those. And then the only thing we're missing for this little triangle is side C right there. So we have sine of 23.2 over C equals sine of 50 over the 12. And I calculate. 12 times sine of 32 divide by sine of 50 will give me a C to be approximately equal to, what do we get? Let's calculate because I don't see the answer. So 12 sine of 23.2 divided by sine of 50 gives me C to be approximately 6.2 units long. So now I have solved for the little triangle. So we had to solve for two triangles here, a little one and we had to solve for a big one. Okay, so if we look back at my original sheet, so we know that if we have side angle of a triangle, it's going to be law of cosine along with side, side, side. Angle, 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 we cannot figure out the side dimensions because if we have no sides for the outer lengths, we're not going to be able to figure out the rest of the triangle. Angle, side, angle, and angle, angle, side will always give me one possible triangle. Okay, so I don't have to worry about finding two triangles there. And side, side angle is a very unique one where I may have 0 triangles, 1 triangle, or 2 triangles. And then I need to look at my table here and follow these rules to see what it is I'm going to have, 1, 2, or 0 triangles. So if we look at one last example, I'm going to say that angle A is equal to 32 degrees. B is equal to 11, and A is equal to 7. So remember, when they're little letters, it means it's a side length, and what's a capital letter and an angle in front of it, it's an angle. So we look at angle A, B, C, doesn't matter in what order we do it. We'll say A is 32, little a is 7, B is 11. So in this step 1, what type of triangle do you have? I have side, side, angle. So that means I have 0, 1, or 2 solutions. Step 2, I look at A is smaller than B. So that means I either have 0 or 2 solutions. So now I need to find the height. The height is dropped. Between the two given sides, we drop an altitude, and we see what is the actual height of this triangle. Sine of 32 equals the height opposite over hypotenuse. So I solve that. 11 sine of 32 gives me, so the height is going to be 5.8. So we look back, the A is greater than the height, therefore I have 2 solutions. So I'm going to have 2 solutions here. So let's do the big triangle first. Triangle ABC. So I know I have the sine of A, which is sine of 32 over 7, is going to give me angle B, because I know the opposite side is 11. If I solve this, I get B to be, angle B will be, angle B will give me 56.4 degrees. And then I know triangle sum, they all have to add up to 180. I subtract 180. I take 180, subtract 56.4, subtract 32, and I should get 91.6. And then I set up for the sine. So I'm looking, the only measurement I'm missing is this length right here, which is little c. So I take sine of c, which I know is 91.6, over c equals, and do the one that I already know. Solve it, and I get c to be approximately 13.2 units long. Okay, so we saw it for the big triangle, but again, it's the little triangle that's a little bit harder to figure out. So we need to solve for the little triangle. So first, let's locate it. We know the side across from the angle given is the side that swings. So this is the swinging side. It's going to swing in, come out, in, out. So I already did the big triangle. We need to swing in. So I'm talking about this triangle right here. And I know that this side length is going to be the same as 7. So the first thing I'm going to figure out is this angle right here. That 32 is for A, right? So again, I have an isosceles triangle. In an isosceles, I found out angle B to be 56.4. Base angles are equal in an isosceles triangle, so that it has to be 56.4. Then the angle I'm looking for, we call it B prime right there. This angle plus 56.4 should add up to 180 because they form a linear pair. So 180 take away the 56.4 gives me B prime to be 123.6. So in the small triangle, angle B prime should be 123.6. Now, coming back up, I already know A is 32. If B prime is 123.6, I can take those numbers from 180 and I will find angle C. So 180 subtract 123.6 subtract 32 should give me 23.2 degrees. And the last thing that I need to solve for, look back at the triangle, is little c right here, this length. So we do sine of this angle C, which we just found. Sine of 23.2 over C gives me, and I use one I already know, sine of 32 over 7. I solve this. I take sine of 7 times sine of 23.2, divide by sine of 32, and I should get C. And C then should be approximately 5.5. Perfect. So I've just solved for a big triangle and a small triangle. Go ahead, I have problems 1 through 16 in the rest of this packet. Give them a try. If you get stuck, just ask me or your teacher.